This is part 2 of lesson 8-1, all about the geometric mean. So in part 1, we talked about how to set up the geometric mean into a proportion where the number that we're looking for, the actual geometric mean, is the denominator in one fraction and the same number as the numerator in the other fraction in the proportion, okay? So now we're gonna actually look at where that comes from in geometry, right? So it's on the worksheet that I've attached here, and we are gonna make it back to this worksheet, but I feel like it's a little, busy, and I wanted to try and simplify it. So here for a second, we're gonna focus on this triangle, okay? So we have triangle ABC. It's a right triangle, and it has a short leg, a long leg, and of course the hypotenuse, which is the longest side, and it's always across from the 90-degree angle. Okay, so if I actually add what I call an altitude, not what I call, but what is called an altitude, which is the height of my triangle, and it's a line that comes from the 90-degree angle, and it's perpendicular to the hypotenuse. So it forms a 90-degree angle here with the hypotenuse, right? Both sides are 90 degrees. What we've essentially done here is created now two smaller right triangles. This is a right triangle, this is a right triangle, and they're similar to this big right triangle. So I've got three right triangles that are all similar, and similar means proportional, right? We took a triangle, we shrunk it down proportionally, and we got this triangle, and we got this triangle, shrinking at a different proportion, right? And we just went over proportional triangles and dilations and all that, so you should be familiar. So right where this altitude touches my hypotenuse here, I'm gonna call that point D. Okay, so now I've got my one big triangle, and it's got the short leg, the long leg, and the hypotenuse. And I've created two smaller triangles. So I've got triangle ABD, and I've got triangle BDC, right? And of course, this big guy, ABC. So this altitude right here is a geometric mean, the length of this altitude. And I'm gonna explain it. I know that sounds funny, but this is really important. So if you take notes or write notes down anywhere, you might see this, this come up somewhere on a test or a quiz, and it'll say, what is the geometric mean between two segments of the hypotenuse? And again, I'm gonna explain, but in triangle ABC, or in a triangle, the altitude is the geometric mean between the two segments of the hypotenuse. And I know we're confused, and I'm gonna explain, I promise. All right, so here, I'm gonna call each of these by their name, each segment, right, by their name. So this is segment AB, this is segment AD, BC, DC, right? So in triangles, this smaller guy over here, triangle, I'm trying to do it in color so it stands out, ABD, and triangle, let's see, we did the smaller corner, BCD. This is similar to triangle BCD. These two triangles are similar, and they're both similar to triangle ABC, but we'll get to that in a minute. We can set up a proportion if we're looking for the length of BD, right? So this is where our geometric mean comes in. Okay, so when you look at a triangle, the lines, every single line, now that we've added this altitude and we've created two smaller triangles, and we still have this one big triangle, every single line segment here represents two things. So this line right here in this triangle represents the longest leg, right? And in this triangle, it represents the shortest leg, right? So I'm gonna write a proportion that shows the longest leg with the shortest leg, right? Or the shortest leg over the longest leg. I'm gonna write short leg over long leg. Short leg over long leg. Okay, I'm gonna write a proportion, and this is how I'm gonna come up with the numbers, right? So in this smaller triangle, my short leg is AD, right? So I'm gonna write line segment AD. My long leg is BD, this altitude. Okay, and that's going to be proportional to short leg over long leg in this other triangle. So what's the short leg of this other triangle? BD. And what's the long leg of this triangle? DC. Okay, so what do we notice here that reminds us of the geometric mean? This guy, right? Remember, in geometric mean, the same number is on the bottom of one fraction and the top of the other fraction. So the number we're looking for is an average, a geometric mean between the lengths of AD and DC. So the geometric mean between this length and this length is this guy. This length is some number in between this guy and this guy. It's the geometric mean. Okay, we also know that each of these small triangles is similar to the one big triangle. So we can say, here, I'll do it in a different color. Doesn't work. Oh, my pens are giving out. It's that time of year. All right, triangle ABC, the whole big thing, is similar to this little guy, triangle ABD. And it's also similar to this triangle BCD. So, and triangle ABC is similar to triangle, what is it, BCD? Okay, so we know those two things are true, so we can keep kind of setting up proportions, right? So we can set up a proportion that shows the kind of double use of AB, which is this guy, okay? So what is AB? Well, in the big triangle, it's the short leg. And in the little triangle, it's the hypotenuse. So I can write short over hypotenuse. Right? So if I do that, short leg over hypotenuse, in the smaller triangle, right? The short leg is AD, the hypotenuse is AB. So AD over AB. And in the larger triangle, it's short leg over hypotenuse. The short leg is AB, and the long leg is BC. Oops, I didn't realize you can see that, sorry. I'm actually going to correct what I just told you. It's short over hypotenuse. I did short over long leg here. So this should be AC. Okay, so short over hypotenuse, AD over AB. This guy over this guy, short over hypotenuse equals short over hypotenuse. The hypotenuse is AC. Okay, so that's what we have here. AD over AB equals AB over AC. So AB is our geometric mean, or it's going to be a number in between AD and AC. AD and AC. The geometric mean between the length of AD and the length of AC is the length of this guy here. That's kind of random, but we did set it up the same way. So short over hypotenuse of one triangle is equal to short over hypotenuse of another triangle. And it just so happens that this length here that's the hypotenuse in one of those triangles is also the short leg in another triangle. So this ends up being a geometric mean proportion, okay? And then when I'm looking at these two triangles, the whole big guy and this little guy, I can set up a different sort of proportion. I can think of long over hypotenuse. So long leg over hypotenuse. And one segment has a double job. It's both the long leg of a triangle and it's the hypotenuse of one. What is that? BC, right? BC is the long leg of the big triangle, and it's the hypotenuse of this little triangle, right? So of the, I'm doing long over hypotenuse, of this little triangle, the long leg is DC, the hypotenuse is BC. So I'm going to do long leg, DC, hypotenuse, BC. That's of the little triangle, and that's equal to the big triangle, same thing, long leg over hypotenuse. Of the whole big triangle, the long leg is BC, the hypotenuse is AC. BC and AC. right? And if you notice, once again, we have a geometric mean proportion because we have the same thing on top and on bottom of our two fractions that are set equal to each other. Okay, so I know that's like confusing. You can't memorize, okay, what goes where? That's not important. The important part is that you understand that once we add this altitude here and we've created two smaller similar right triangles to this one big right triangle, now every single line segment has a double use, right? Again, AB is the hypotenuse of this little guy and it's the short leg of the whole big thing. BC is the long leg of the whole big triangle, and it's the hypotenuse of this little guy. BD is the long leg of this little guy. It's the short leg of this triangle, right? Everything has a double use. All right, so that's what we're talking about in this lesson. Can I back up at all? Not really. If you want to pause this and write that down just to move forward. The whole picture of everything, I can't really... Okay, so we're going to use that to look at some problems here. All right, so we're going to solve, we're going to do some math and solve using geometric mean. So if we have 6 problems here we're going to do together. We have to solve for X, Y, and Z. Some problems don't have all 3 letters. Some of them do. I'm going to start on this paper that I just used. So I have to show my work on a different sheet of paper. So I'm going to use this one I just started writing notes on. I'll write it off here to the side. Okay. So I'm going to solve for these using the geometric mean equation, but I got to figure out what goes where, right? For this first problem, it's pretty simple because we're looking for X, right? And we already talked about this is the altitude. So this is a geometric mean between this and this, right? So if you want to think of it this way, you can think of this one. This guy right here is the short leg of one triangle and the long leg of another triangle. So I'm going to write, for number 1, short over long. And I'm going to write my 2 equations showing that. So for this smaller triangle, the short leg is 1, the long leg is X. So 1 over X. For this bigger triangle, the short leg is X, the long leg is 3. Okay, and I want to solve for X, the length of X, right? So of course, geometric mean, we cross multiply here, cross multiply here, and I get X squared equals 3. And then to solve for X, I have to take the square root of both sides, right? So X is going to equal the square root of 3. And I can't simplify that anymore. It's a prime number underneath there, so I'm done. Okay? So here I solved for X, square root of 3, I'm finished. That was an easy one. They get harder from here. All right, number 2. Now I've got more to solve for. Okay. Here I have an X, a Y, and a Z for number 2. So I got to figure out where I can start and start going. I'm going to solve for X first, right? So X actually represents 2 things. It's the short leg of this triangle, and it's the long leg of this triangle, kind of just like we looked here. So I'm going to do short over long. You don't have to write this step right here. I just write it to keep myself, like if I keep it in my brain, then eventually I get confused when I'm doing all this. So I got to write it down to keep myself on track. Okay, short over long. So it's the long leg of this first guy. So the short leg is 2, the long leg is X. And of this big guy, the short leg is X, the long leg is 5. Right? And then I can do my math to solve from there. So I cross multiply, and I get X squared equals 10. Take the square root of both sides, and X equals, I can't simplify the square root of 10 because it comes from 2 and 5, and they're both prime numbers. So I'm done. If one of my factors was a perfect square, then I could simplify, but they're not, so I'm done. Okay, so there's X. I know X is square root of 10. Now I want to solve for Y. Okay, so what are Y's jobs, right? It's the short leg of this one big triangle, and it's the hypotenuse of this little triangle. So I'm going to write an equation or a ratio for short over hypotenuse. I got to make sure that my ratio includes both jobs of the, where am I at here? Both jobs of the variable I'm trying to find. Since I'm trying to find y, both their jobs, it's either the short leg of this guy or the hypotenuse of this guy. Short and hypotenuse have to put in ratio. Okay, so for the smaller triangle, short over hypotenuse is 2 over y. And for the bigger triangle, this whole big thing, short over hypotenuse is y over this whole thing. And this whole thing is made up of 2 plus 5, which is 7. So y over 7, short over hypotenuse. Okay, once we have our proportion set up, we cross multiply, and I get y squared equals 2 times 7, which is 14. Take the square root of both sides. Y equals square root of 14. We can't take the square root of 14 without getting a decimal because it's not a perfect square. We get some long irrational number, so we just want to leave it like this. And then, of course, I can't factor anything because it's made up of prime numbers, right? So this is y. And now I have to solve for z. And what are z's two jobs right now? Z is the long leg of this whole big triangle, and it's the hypotenuse of this smaller triangle. So I need to write a ratio with the long leg and the hypotenuse. So I'm going to write long over hypotenuse. Okay, so I start with the smaller triangle here. The long leg is 5, the hypotenuse is z. And then the bigger triangle, the long leg is z, the hypotenuse is 2 plus 5 is 7. Whenever I write my ratios, I always start with the smaller triangle ratio and then I move to the bigger triangle ratio. That seems to help. All right, and so now I cross multiply. Z times z is z squared. 5 times 7 is 35. I take the square root of both sides and I end up with just z equals 35. This is a bigger number, so it seems like you could factor it, but when we break it down, it's made up of 2 prime factors, so we can't factor it at all. Okay, so I solved for x, y, and z for number 2 here. And they're all under the radical sign, but that's okay. It doesn't matter what the answer is, as long as we found it correctly. That was for number 2. Okay, number 3, solving the exact same way. I'm scared to try and write on the paper because I think I'll run out of room. I'll just move to here. Okay, so we want to solve for x, y, and z. I'm going to start with x here. For x, I can do x first. X is the short leg of the whole big triangle, and it's the hypotenuse of the smaller triangle, right? So short and hypotenuse. I'm going to write short over hypotenuse. And then I want to write my 2 ratios. So for the smaller triangle, short leg is 1, hypotenuse is x, 1 over x. And for the bigger triangle, the whole big thing, the short leg is x, the hypotenuse is 1 plus 8, which is 9, x over 9. So I get this guy, I cross multiply, and I get x squared equals 1 times 9 is 9, and then I take the square root of both sides. Square root of x squared is x. The square root of 9, it's a perfect square. The square root is 3. So that was a nice clean answer. Okay, so there's x. Now I gotta find y. Can I do y next? Yeah, I can do y next. Y, what are y's 2 jobs? It's the long leg of this big triangle, and it's the hypotenuse of the smaller triangle. So I'm gonna write long over hypotenuse. All right, long leg over hypotenuse. So for the smaller triangle, the long leg is 8, the hypotenuse is y, 8 over y. And for the bigger triangle, the long leg is y, the hypotenuse is 9. Then I cross multiply. And I get y squared equals 8 times 9, which is 72. Okay, and then I take the square root of both sides, and I get y equals the square root of 72. And now I can factor the square root of 72. So we'll do this off to the side here. 72 under the radical, I can factor it. So I can divide it by 2 and 36. Oh, I know 36 is a perfect square, so 6 and 6. My goal, I can keep factoring it from here, but remember, my goal is to find numbers that I can square to put under the radical, right? So I can keep going and I'll end up with the same answer, but I already have numbers I can pair up here, so I'm done. So this was a prime number. These aren't prime numbers, but they're a pair of numbers, so I can be done. Right, so I'm going to rewrite square root of 72 as 2 times 6, which is 6 squared. Right, and then this 6 has this 2, which is its ticket out, and it hops out front. So it's 6 times the square root of 2. Let me just show you. If we had factored that further, 72, if I factored it into 2 and 36, and I went 6 and 6, and then I went 2 and 3, and 2 and 3, these are all prime numbers. It's a dead end. I rewrite this as 2 times 2, which is 2 squared. 3 times 3, which is 3 squared. And then I had this 2 left over. Right? And then these guys both have a 2. They have a ticket out. And so once they're out here, I multiply them together. 2 times 3 out here is 6. And then I still have this 2 left over. See, it's the same thing. As long as you can pair up numbers to give them that little 2 under the radical, that's what you want. That's the goal. This little 2 is its ticket out front, and that's what you want to do is get numbers out front. Okay, so anyways, square root of 72 is the same thing as 6 square root of 2. So this is our simplified answer. Hopefully you guys are doing okay with that, following well. Sorry with the sun, I got a window open behind me here. And then lastly, I have to solve for z. Z has, oh, you can't see that, can you? Where am I at? Oh, just kidding. Yeah, z. Z here has 2 jobs. It's the long leg of the smaller triangle, and it's the short leg of this medium triangle, this bigger triangle, right? So I need to write a proportion with short and long, right? So I'm going to put short over long down here. And then for the smaller triangle, short leg is 1, long leg is z, 1 over z. For the bigger triangle, the short leg is z, the long leg is 8. Hopefully it's all starting to like look the same because we literally are doing the same thing over and over. This is all geometric mean. It just gets jumbled up because so many things have a double meaning, and so you kind of forget in your head sometimes. All right, so z squared equals 1 times 8, which is 8. Take the square root of both sides. Z equals square root of 8. And we could actually factor 8. It's a small number, but we actually can factor it. So 8 is 2 and 4. And 4 is a perfect square, right? So we have 2, 2, and 2. When we rewrite it under the radical, instead of square root of 8, I'm going to write square root of 2 times 2 times 2. 2 times 2 is 2 squared. And then anything with this little squared symbol, it's its ticket out, so it hands it over and it hops out front. 2 square root of 2. So z equals 2 square root of 2. Okay, so those are our 3 answers for x, y, and z for this problem. And I'm going fast because I know with it being on video, you can always pause it and rewind. All right, number 4. Number 4, still solving the exact same way. There are no exceptions. We're just gonna keep going. For number 4, I'm saying there's no exceptions. There are 0 exceptions to the rules. Number 4 is actually an easy one because we are gonna start off using geometric mean, but we don't have to, you'll see once we start solving. Okay, number 4. we're gonna say to solve for x first. X is the short leg of one triangle, and it's the hypotenuse of another triangle, the smaller triangle. So we're gonna say short over hypotenuse. And then for the smaller triangle, the short leg is 1, the hypotenuse is x, 1 over x. For the whole big triangle, the short leg is x. The hypotenuse, oh crud. Oh, this is what I wanted to look at. The hypotenuse is y plus 1. Okay, so we can't go any further. Oh, sorry. We can't go any further here, right? Because we don't know what y is. But what are we looking at here? Short over hypotenuse, right? Short over hypotenuse, short over hypotenuse. Is there another triangle that has a short leg and a hypotenuse? I had this little guy. I had this whole big guy. What about this guy? What's the short leg and the hypotenuse? Square root of 3 over square root of 12. There are no variables in that. So I'm going to use that. The short leg over the hypotenuse is square root of 3 over square root of 12. So I'm going to, even though this is geometric mean and I'm solving for x, I actually don't need the geometric mean to solve for x in this problem. Where did 4 go? Here. Right? I didn't need it. I know how to set up the ratios, but I didn't have to have x on the bottom and x on the top. I can actually just ignore this right now since I don't know what y is and do short over hypotenuse here and compare it to short over hypotenuse here. It's the same ratio, right? And then I can cross multiply. So 1 times square root of 12 is just square root of 12. X times square root of 3 is x square root of 3, right? Now here's where it gets a little tricky because this is not simplified. We have to simplify this radical and then you'll see how we can find the answer. So how do I simplify square root of 12? What can it be divided by? What about 4 and 3? And that can go into 2 and 2. And these are all prime numbers, so we're done. Okay, so then if I rewrite that, that's 2 squared times 3. And this 2 has this little ticket out, so it hops out front, 2 square root of 3. So square root of 12 is the same thing as 2 square root of 3. So I can rewrite it here, 2 square root of 3, and that's equal to x times the square root of 3. So then what must x be, right? We can divide both sides by square root of 3. These cancel, and I'm left with 2 equals x. Right? So there's no exceptions to the geometric mean rule. We just happen to not need to use it in this problem. So we know x equals 2. And then we had to solve for y. When we're looking at this, y, I mean, it has two meanings. It's the long leg in one triangle, but it's only part of the leg in another. I don't know. That gets confusing, right? But I know what x is now. And didn't I use y up here? I marked it out because I didn't know what it was, but didn't I have a proportion set up? I had 1 over x equals x over y plus 1. And now I know that x is 2. So 1 over 2 equals 2 over y plus 1. Couldn't I solve this for y? If the goal is to solve for x and y, can I do that? They're two equal ratios. Right? Absolutely. All right, so it really is still geometric mean. I'm just not solving for the geometric mean. I'm solving for one of the numbers you find the mean between. Okay, so cross multiply this way, that's 4. Cross multiply this way, 1 times y plus 1 is just y plus 1. And then subtract 1 from both sides. 4 minus 1 is 3, so y equals 3. Okay, I hope you were able to follow that. It wasn't difficult, but mixed in here with this geometric mean stuff, it gets confusing. All right, I promise you the next two are strictly geometric mean. They're not goofy like that. All right, number 5. Let's scoot it over, give myself room. Okay. All right, so here we have x, y, and z. Okay, we've got this 90-degree angle. We've got this altitude, it's 2. We know all three angles are similar, right? What do you notice about this triangle? This is a smaller leg, this is a smaller leg, this is the hypotenuse. What do you notice about the two legs? They're the same size. They're the same. Means it's an isosceles triangle, right? So if these are the same size, then in this triangle, these have to be the same size. So I don't even have to do any math to know that x is 2. Because it has to be the same size, right? This is 2. Okay? Then I also know that of the whole big triangle, these two legs have to be the same. Z has to be equal to y. So now I just got to figure out how to solve for one of them, right? So pick one. It doesn't matter which one. They're the same thing, right? So let's say Z. What are Z's two purposes in this triangle? Well, it's the leg of the big triangle, and it's the hypotenuse of this smaller triangle, right? So leg and hypotenuse. So I'm going to write leg over hypotenuse. And it doesn't matter if it's the shorter or the longer leg because they're the same thing in this triangle. Okay, so leg over hypotenuse of the big triangle. I'm going to write the leg over the hypotenuse. That's, I'll start off with the little triangle first, sorry. The little guy is leg, which is 2, over hypotenuse, which is Z. And then in the big triangle, the leg is Z. And the hypotenuse is this whole guy, which is 2 plus 2, 4. If I had written it the other way, which I almost started to do, I almost wrote Z over 4 equals 2 over Z. That's okay, right? We want to keep it consistent. Geometric mean, we want it to go this way. But here, it's still on the top of one fraction and the bottom of the other. And when we cross multiply, we get the same thing as when we cross multiply here. So if you do end up with Z at the top and the bottom here instead of the bottom and the top, it's okay. Don't freak out. You didn't do anything wrong. It's the exact same answer. I'm just trying to keep everything consistent. Okay, so then we cross multiply and I get Z squared equals 2 times 4, which is 8. So Z equals square root of 8. And then, of course, I already found earlier that I can simplify square root of 8 into 2 square root of 2. So Z equals a 2 square root of 2. And up at the top of this, I already said Z and Y are equal, so that means Y equals 2 square root of 2. Easy peasy lemon squeezy. Okay, one more problem, number 6 here. This is back to the long way, right? There's no shortcuts to this one. Let me get a separate sheet of paper. Number 6. Scoot over a little bit. There we go. The struggle is real finding space to fit everything in the phone camera for you guys. Woo, okay. Number 6. Here, we have to find x, y, and z. For x has two functions. It's the hypotenuse of this smaller triangle, and it's the short leg of this bigger triangle. Okay, so hypotenuse and short leg. So I'm going to write short over hypotenuse. Another thing I always try and do whenever I'm writing my ratios, you could have written hypotenuse over short. That's fine. That's perfectly fine. I always try and write whatever the shortest leg is on top. So if it's short and long, I write short over long. If it's long and hypotenuse, I write long over hypotenuse. I always put the shortest leg and the longest leg, top and bottom. Okay, anyways, so short and hypotenuse for x. In the smaller triangle, the short leg is 2, the hypotenuse is x. In the bigger triangle, the short leg is x, the hypotenuse, it tells us, is 6. Okay, so then I can cross multiply, solve for x here. That's x squared equals 2 times 6 is 12. And in the last example, I just figured out what 12 is when I simplify, or maybe that was number 4. Square root of 12 is the same thing as 2 square root of 3. Oops, that wasn't squared, there's just x. X equals 2 square root of 3. Don't do double work. If you already figured it out in the last problem, just use that in this problem. Okay, so that's x. Then I want to find, this. Oh, keep moving. There, okay. Then I want to find y. Y has two purposes. It's the long leg of the smaller triangle and the short leg of this bigger triangle. So I'm going to do short over long. And in the smaller triangle, the short leg is 2, the long leg is Y. In the bigger triangle, the short leg is Y, the long leg is what? Well, I know the whole thing is 6, and I know this piece is 2, so 2 plus what equals 6? 4. So the long leg here is just 4. Then I just cross multiply. Y squared equals 2 times 4 is 8. And I also already found out what the square root of 8 is when I simplify. 2 square root of 2. I did that in one of the earlier problems as well. So I've got X, I've got Y. Now I got to find Z. Z is where? This guy. So it's the long leg in the big triangle, and it's the hypotenuse in the smaller triangle. So I'm going to do long over hypotenuse. In the smaller triangle, the long leg we just said was 4. Hypotenuse is Z. In the, the bigger triangle, the long leg is Z, the hypotenuse is 6. All right, your main goal, remember, and I said it doesn't matter if Z is here and here or here and here, but your goal is when you use geometric mean that the number you're looking for is, if it's the geometric mean, is on bottom of one ratio and on top of the other, right? So if you had Z and a number equals Z and a number and they're both on top, you probably didn't do something right, okay? So make sure you set the geometric mean part up correctly. Z squared equals 6 times 4 is 24. Z equals square root of 24 because we took the square root of both sides. And then absolutely we can factor 24, right? Let's go over here. Square root of 24, I can do 2 and 12. That's a prime number too. 12 I can separate into 3 and 4. 3 is a prime number. 4 is a perfect square. Separate it into 2 and 2. So then I can rewrite it. Square root of 2 times 3 times 2 times 2. 2 times 3 times, and then 2 times 2 is 2 squared. So the only number here that has a ticket out of the radical is this 2 at the end. It hands over the squared, it comes out front, and then 2 times 3 is left under the radical. We can go ahead and multiply it back. 2 square root of 6. So Z equals 2 square root of 6. All right, so that's my 3 answers here for number 6. Okay, hopefully those 6 examples didn't confuse you too badly, showed you what some of these might look like on your assignment. I'm hoping to see a lot of work from you guys. For this week that I'm making the video, I'm putting it up late. I was out sick on Monday. I apologize that I'm getting everything put in late, but I did give you until Sunday to submit everything, so you have a couple extra days. Okay, let me know if you have any questions.